Now, this is quite a story from NASA because for the second time in history, a man-made object has left our solar system. NASA is saying the Voyager 2 probe is now in a space between the stars after exiting the sun's protective bubble, which is called the heliosphere.
At the far reaches of our solar system, in a realm where sunlight fades to a ghostly glimmer and the wind from the sun becomes a whisper, Voyager 2 has once again crossed a threshold that stirs both awe and curiosity. Having already etched its place in history by exploring the outer planets decades ago, this venerable spacecraft, launched in 1977, has now sent back new and unprecedented data from the edge of the heliosphere, the boundary that separates the influence of our sun from the interstellar medium. This recent encounter, a silent crossing into a region dominated not by our solar wind, but by the charged particles and magnetic fields of the galaxy beyond, offers a direct look into a place no spacecraft has physically measured quite like this before. Before we start, smash the like and subscribe buttons for more updates. Voyager 2's entry into interstellar space is not just a geographic milestone, it is a scientific revelation. As the spacecraft pierced the heliopause, the invisible curtain where the outward pressure of the sun's solar wind is balanced by the pressure of particles from the rest of the galaxy, it encountered dramatic changes in its environment. One of the first and most striking signals of this transition was a sudden and lasting drop in the detection of solar particles, those high-energy fragments of the sun's breath. Simultaneously, instruments aboard Voyager 2 recorded a corresponding and sharp increase in cosmic rays, energetic particles originating far beyond the solar system. This surge confirmed that Voyager 2 had finally entered a space shaped not by our sun, but by the wider cosmos. This event was monumental because it gave scientists a second data point to compare with Voyager 1, which had crossed into interstellar space in 2012, but on a different trajectory and under different solar conditions. Unlike Voyager 1, which had experienced a complex and somewhat chaotic transition with fluctuating magnetic fields and particle densities, Voyager 2's crossing was smoother and provided more comprehensive data. This is because, uniquely, Voyager 2 still had a functioning instrument capable of directly measuring the solar wind plasma, a tool that Voyager 1 had lost years earlier. With this critical capability intact, Voyager 2 delivered real-time measurements of the plasma environment as it crossed the heliopause, allowing scientists to determine the exact moment when the solar wind faded and the interstellar medium took over. The spacecraft recorded a remarkable change in the density and temperature of the plasma around it. Inside the heliosphere, the plasma was relatively warm and diffuse, expanding outward from the sun. Beyond the boundary, however, Voyager 2 detected plasma that was nearly 40 times denser and much cooler, yet it wasn't moving outward from the sun. This interstellar plasma, shaped by forces beyond our solar system, seemed to fill the void in a stable, non-expanding fashion, revealing an environment shaped over billions of years by supernovae and the remnants of distant stars. Such detailed observations helped scientists confirm long-held theories while challenging others, particularly about the nature and structure of the heliosphere itself. The magnetic field measurements offered further intrigue. As Voyager 2 crossed the threshold, the direction of the magnetic field shifted subtly, though not dramatically. This differed from Voyager 1's experience and suggested that the boundary itself may be more complex and variable than previously assumed. The observations hinted that the heliopause may not be a single clear-cut surface, but rather a dynamic and fluctuating frontier, molded by both the sun's long-reaching magnetic fingers and the vast galactic forces pushing against it. The fact that Voyager 2 entered this space during a relatively quiet period in the sun's 11-year activity cycle may have allowed for a cleaner crossing and more pristine measurements of the interstellar environment. What Voyager 2 saw at the edge of the solar system was not just a passive region of transition. It was an active and evolving interaction zone, a cosmic handshake between our solar system and the rest of the galaxy. The spacecraft picked up signs of what scientists call interstellar shocks, which are ripples of energy caused by solar outbursts that travel outward and eventually interact with the interstellar medium. These shockwaves can compress the boundary and send particles slamming back into the heliosphere, creating a kind of echo of solar activity long after it was emitted. By tracking these shock events, scientists now gain insight into how solar phenomena propagate far beyond the planets, affecting regions previously thought to be unchangeable and static. In a way, Voyager 2 has become a deep space weather station, reporting from the front lines of an invisible battle between the sun's influence and the galactic tide. The interstellar medium is not empty. It is filled with ionized gases, dust, magnetic fields, and cosmic rays that were once part of stars that lived and died long before our sun ever formed. As Voyager 2 traverses this ancient sea, it acts like a scout for humanity, sampling the primordial conditions of the wider galaxy. These measurements are not just academic, they help define the very nature of the bubble in which we live. Understanding the shape and behavior of the heliosphere can tell us about the shielding effect it provides. Earth and the other planets are cocooned within this magnetic shell, protected from much of the galaxy's harshest radiation. Learning about its strength, permeability, and structure could help explain how life on Earth has been nurtured and how other life elsewhere in the galaxy might also survive or struggle. The timing of this new data from Voyager 2 is also significant. With the spacecraft now more than 12 billion miles from Earth, every bit of information takes over 18 hours to reach us, traveling at the speed of light. Its power supply is dwindling, with instruments slowly being shut down to conserve energy. Yet even in this final phase of its mission, Voyager 2 continues to deliver some of the most vital scientific discoveries of our time. The spacecraft's ability to operate in such a remote and hostile environment is a testament to both engineering endurance and the insatiable human drive to explore. The heliopause, as revealed through Voyager 2's experience, is not a wall, but a veil, porous, fluctuating, and reactive. This nuanced picture challenges the old image of the solar system as a self-contained sphere. Instead, we see it as a fluid entity, its edges shaped and stirred by the galaxy it drifts through. Voyager 2 has helped trace the boundary of influence, where the sun's magnetic field and charged particles give way to forces billions of years older and orders of magnitude broader. Every particle it measures, every signal it transmits, extends a map into a territory humanity has never touched before. The implications of these discoveries ripple across disciplines. For astrophysicists, Voyager 2's observations inform models of how stars interact with the galaxy and how solar systems evolve. For planetary scientists, the data helps explain how cosmic radiation shapes atmospheres, perhaps even playing a role in the chemistry that leads to life. And for engineers, Voyager 2 stands as an example of how to build machines capable of reaching beyond what was once thought possible. Machines that persist, adapt, and continue to work decades beyond their planned lifespan. One of the most compelling outcomes of Voyager 2's recent observations is the realization that the heliosphere may act more like a living membrane than a rigid shell. It breathes with the cycles of the sun, it ripples with cosmic influences, and it interacts dynamically with the space around it. In practical terms, this could mean that the boundary is constantly shifting, sometimes expanding outward during solar maximum when the sun is active and powerful, and sometimes retreating during solar minimum when its energy ebbs. The precise measurement of these changes offers a new window into the rhythms of our local galactic neighborhood. This also redefines how we think about the edge of our solar system. While traditionally defined by the orbit of the farthest known planets or the extent of the sun's gravity, Voyager 2 has revealed that the true edge is energetic and magnetic rather than gravitational. It is the boundary of influence, not ownership, a threshold where the forces that once governed begin to fade and new ones take their place. Crossing that boundary, Voyager 2 has transitioned from being a solar probe to becoming an interstellar traveler, a change in mission that reflects a deeper shift in humanity's exploration of space. Voyager 2's voyage into the interstellar medium also lays the groundwork for future missions. Concepts like the interstellar probe, currently under study by NASA, seek to build on Voyager's legacy with more advanced instruments and faster speeds, but nothing will ever replace the uniqueness of Voyager 2's perspective. It is a first-of-its-kind encounter, unrepeatable in time and conditions, capturing a snapshot of the solar system's frontier at a particular moment in cosmic history. Every particle count, every magnetic field twist, every plasma density fluctuation adds to a growing archive of how our star and its domain blend into the galactic tide. Beyond the technical data, there's something deeply philosophical in what Voyager 2 has shown. It has gone so far that our sun, once a dominating presence, now merely whispers in the background. In this silence, the spacecraft listens to the echoes of distant galaxies, to the hush of particles billions of years old. It is no longer in a place shaped by us, but in a space that is truly other. And yet, through this tiny spacecraft, our voice continues to travel outward, a testament to the enduring desire to know, to reach, to push beyond. The heliopause marks a milestone not only in distance but in understanding. Voyager 2's crossing revealed that space beyond our sun's reach is neither barren nor dead. It is full of movement, energy, and complexity. The interstellar medium is alive with currents of its own, and now, for the first time, we have begun to taste its flavor directly. As Voyager 2 drifts farther into this vast unknown, it carries the story of a small planet's bold reach. It shows that the boundary of the solar system is not the end, but a beginning, the first page of our direct engagement with the galaxy beyond. And while Voyager 2 continues on its silent trajectory, its data fuels a revolution in our understanding. Each signal received is a whisper from a place untouched by any hand, a place that until now existed only in theory and imagination. It has bridged the gap between what we knew and what we now begin to grasp. That the solar system is a ship adrift in a much larger sea, and we have just glimpsed its shores. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on what Voyager 2 will find at the edge? We want to hear from you. Thank you for watching and see you next time.